Good evening, everyone. Hope I'm audible and visible to each of you. If I am, then please raise your hands. Great. Awesome. So it's an absolute pleasure to start off a new course, which is the CUET crash course, and a very warm welcome to each of you. Let me introduce myself. My name is Samkit Bantia, and I'm a co-founder at EduSure. And I look at the math and the statistics and the microeconomics area in a few of the courses at EduSure, right? Before we begin, I want to introduce a very, very special faculty that we have today with us. Uh, Dr. Suman is a part of EduSure, and she shall be taking up the mathematics course along with me for the CUET crash course. Whatever I say about her will be less. She is a BSc in mathematics from KMC College, Delhi University, has been a topper throughout her life, having secured a prime minister box in the brigade of the 26th of January, which is extremely coveted. Having taken IIT entrance examination for her masters, she got a rank of 4 in IIT Jam, and she has also done her PhD from Delhi University, and been associated with so many colleges over her amazing career. We are extremely lucky to have her, but more importantly, the love that she has for the subject sets her apart. She takes mathematics from absolutely rudimentary level, and she ensures that each and every student in her class is able to follow whatever she is doing in class. So having said that, I'll give the mic over to Suman ma'am. Ma'am, over to you, and thank you so much for being a part and starting of the CUET crash course in the mathematics area. Thank you, ma'am, once more.
Thank you, sir. Thank you for such a nice and warm welcome. Hello, everybody. I'll be taking your mathematics classes for CUET. Before that, I would like to tell you a little bit about the course of mathematics, what comes in CUET examinations. So basically, let me share my whiteboard with you. Okay. So your course has these topics. We have matrices and determinants. I will give you a broad outline of your syllabus. We have functions, okay? When we talk about functions, we have basics, domain, range, inverse, increasing functions, decreasing functions, concave functions, convex functions, etc. And for the calculus, we have differentiation, integration, limits, continuity. I'm writing all those things that have been asked in the previous question papers. Okay. Then we have linear programming. We have linear programming. We have little bit of differential equations. We have difference equations. We have sets. We should know basics of logs. Okay. Now, you should not get scared by looking at this syllabus. What is expected from you is that you should know basics. Your basics must be very, very strong, because sometimes you know how to do a very difficult question, complicated question, but you get stuck at definitions. So we have to focus on definitions because CUET targets definitions. They will ask you conceptual questions, not very difficult questions, conceptual questions. Okay. So basically what we can expect class 12th mathematics level or basic college math. That is what we can expect. Okay. So having said that, I would like to start my class with differentiation and integration. So let's start. Okay. Now, they sound very complicated. Differentiation. जैसे ही हम लोग डिफरेंशिएशन या इंटीग्रेशन की बात सुनते हैं जनरली हमें डर लग जाता है. ओके, डरने वाली कोई बात नहीं है. व्हाट इज डिफरेंशिएशन? होता क्या है डिफरेंशिएशन? ओके, बेसिकली पहली बात तो वी विल हैव अ कर्व. We will have a curve of the form y equals to fx. It means y will be explained in terms of x. Okay, example, you can have y equals to x, you can have y equals to x square plus x, you can have y equals to log x, you can have y equals to log x upon sin x, and so on. So basically what we are doing, we are explaining a relationship of between x and y, where y is sometimes explicitly expressed in terms of x, sometimes not. For example, sometimes we can have this kind of a equation. Okay, so here we will okay, here we will not be able to isolate y in terms of x. So we will meet both kind of these conditions in our class. So basically what are we dealing with? We are dealing with functions. Now what is differentiation? Why? What do you mean by d by dx of y? What is this thing? D by dx is basically an operator. This is a machine. Okay? In simple language, it is a machine which is operating on my function y. And what is it giving me? It is giving me rate of change of y with respect to x. Okay. And since you are economic students, it comes very handy. Suppose you have a cost function, okay, in terms of x, where x is the number of units. Now, what is d by dx of cx? D by dx of cx is nothing but your marginal cost. Whatever hi-fi terms that we talk about, these are actually rates of change. Now, if Rx is your revenue function, what is d by dx of Rx? That is your marginal revenue. I don't need to get into the details of economics, but that is the application of derivatives. So basically, you know, one might wonder, why do we need mathematics? We need mathematics because we are dealing with day-to-day rates of change. Okay. Now let us start with formulas. This was just to motivate you, just to give an insight what we actually mean by differentiation. They are basically operators. We will input functions, and what answers we are going to get? We are going to get rates of change in return. Okay. Let's start. Okay. Now, I will write my function here. I will write my y here, and I will write my dy by dx here. Okay. Now, if my y is of the form x raised to the power n, where n is a constant, okay, then my dy by dx will be n x n minus 1. Okay. If my y is sin x, it is going to be cos x. If it is cos x, it is going to be minus sin x. If y is tan x, this is secant square x. I am writing these formulas because in examination sometimes they will just ask you direct formulae. So you should know them, and they have been asked as far as integration is concerned. So if it has been asked in integration, be ready that the direct formulas can be asked with respect to differentiation as well. Okay. Now, suppose I want to find the differentiation of sec x. It is going to be sec x tan x. You can add these to your list. These are going to come very handy. Cosec x, cot x. Then we will have differentiation of cot x, which is minus cosec square x. Differentiation of e raised to the power x is e raised to the power x. Differentiation of a raised to the power x is a raised to the power log of a. So these are some standard formulas which I am writing here. We can add to this list later on. Okay, so these are the formulas. Now, okay. Now, in 2020 CUET, they just asked you what is the derivative of x raised to the power half. Okay, such a simple question. X raised to the power n is a constant. So my n over here is half. So the answer would be half x raised to the power half minus 1, which is half x raised to the power minus half. Okay. Now it can be given in this form in your options. Okay. Such a simple question. That is why we should know the formulas. Okay. All right. So these are the formulas for differentiation. Now we will be doing some questions related to them which have come in your CUET examination. Let us start. Now, this question was asked in 2023. Okay. And this is question number 38. It was given that x under root 1 plus y under root 1 plus x equals to 0. Okay. This equation was given to us and they asked us to find out dy by dx, where the options were minus 1 upon 1 plus x whole square, option B 2 upon 1 plus x, option C minus 1 upon under root 1 plus x, and option D 1 plus x upon 1 plus 1. Okay, so with this question I will explain you a lot of things about differentiation. We need to find out this. So what am I going to do? I'm going to make it simple. First of all, let me bring this to the right hand side with the change in the sign. Plus becomes minus. So it becomes minus y Okay. Now we square both the sides. So we will have x square 1 plus y equals to, now when I square this negative sign goes away. I will have y square 1 plus x. Now let us try to expand. X square plus x square y equals to y square plus y square x. X square minus y square equals to y square x minus x square y. A square minus b square. A minus b into a plus b. X square minus y square. X minus y into x plus y. This is equal to, we take xy common here, we will have y minus x. Now, what we do, we bring this thing on the left. So we will have x minus y, x plus y minus xy, y minus x equals to 0. So we will have x minus y, x plus y. We will have x minus y. Let's take it common. Okay, this will become x minus y. Let me take one more step. This will be x minus y, x plus y plus x minus y into xy equals to 0. Now we can take x minus y common. So we will have x plus y plus xy equals to 0. Now, this much algebra we should know when the product of two expressions is 0, then either this expression should be 0 or this expression should be 0. What does it mean? It means either I will have x minus y equals to 0 or I will have x plus y plus xy equals to 0. I hope this much is understood. When we have the product of two expressions as 0, we must have either of these expression equal to 0. Both can be 0, but either of them should hold. Now, let us discuss the cases one by one. Okay. Now, what if x minus y equals to 0? It means x equals to y. Now, it means dy by dx. Now, this is x raised to the power 1. So, the differentiation of x raised to the power 1. Let us do it from a grassroots level. 1x, 1 minus 1, 1x power 0, 1. So, I do not have these answers over here. That means I should go to this equation now. This equation has not fetched me my answer. Okay. So, let's see. Just wait for some seconds. This question is very important. This is explaining us a lot of concepts. This is also giving us an insight into what CUET is up to. Not very difficult questions. Basic algebra required over here. Algebra plus calculus. Okay. X plus y plus xy equals to 0. So y 1 plus x equals to minus x. So y equals to minus x upon 1 plus x. So basically I have now explicitly defined y in terms of x. And now the only task that remains is to find dy by dx. Now with this, I would like to introduce the quotient rule of derivatives. That means we should know what is the quotient rule of derivative. What happens if we have two things like one numerator, one denominator? How do we differentiate such functions? Because till now I have only discussed, these basic formulas with you. I have not told you what happens when we have a numerator and a denominator. I have not told you what happens when the functions are in addition. I have not told you what happens when there are two functions which are in product. So we will discuss them one by one. Now we will stop at this and now we will do quotient rule of derivatives. Let's see. So what is quotient rule of derivatives? It says if y is expressed as a quotient of two functions, okay, then my dy by dx would be gx whole square gx f d by dx of fx minus fx d by dx of gx. So what are we doing? We are squaring the denominator. Then in the numerator, we keep gx as it is. We differentiate f minus we keep f as it is and we differentiate this g. Now with this, I am going to differentiate this. Let's see how it is going to be done. First of all, this minus sign can be kept outside. This is my fx and this 1 plus x is my gx. Okay. So my dy by dx will be 1 plus x whole square. Okay. I will keep 1 plus x as it is. I am going to differentiate x. Differentiation of x is 1 minus x. And I am going to differentiate 1 plus x over here. Now, differentiation of 1 plus x. Here you will recall or you will try to learn that when I have two functions in addition, the derivatives can be separated. Okay. The rate of change of any constant is 0. Okay. If you go by the definition, the rate of change of any constant is 0. And again, the rate of change of x is 1. So this is 1. So dy by dx will be minus 1 plus x minus x upon 1 plus x whole square. And that would give me minus 1 upon 1 plus x whole square. So you see, let's see. Yes. So this is correct. Now why this question was important? Okay. This question is important. First of all, it teaches us how to get rid of these square roots, because these square roots look very complicated. Okay, so we got rid of the square roots. Then we used the property that if the product of two expressions is 0, then either of the expression will be 0, and then we tried to find out the derivative. So this question is completed, and we have learned quotient rule of derivative. This is known as quotient rule of derivative. Very important, very basic. Okay, now I will write down some rules. So, rules. Okay, number 1, if I have two functions, fx and gx, and I'm adding them, I can separate the derivative. Then, if similarly with the difference, then if I have some constant multiplied with the function, I can take this constant out. Third, product rule. Now, very careful. There is no such rule. There is no such rule which says this is going to happen, and there CUET can twist you. Okay, they can give you product of two functions, and people can do this. This mistake is very common in differentiation. People are given product of two functions, and what they do, they multiply the respective derivative. This is incorrect. This is a warning. You can write down the warnings. You will remember them first. Okay, now what is product rule of derivatives? I take the first function outside and I differentiate the second function. Plus, I take the second function outside and I differentiate the first function. Okay? For example, if you want to find out the differentiation of x into sine x, this is first, this is second. So you keep x as it is, you differentiate sine x, and then you keep sine as it is and you differentiate x. So your answer will be x cos x plus sine x. And CUET can confuse you. They can give this as an option. D by dx of x is 1. D by dx of sine x is cos x. This will be 99.9%. If they are asking you this question, they will give you this as an option, because this is a very easy option. Okay, don't get tempted by it. Please focus on your basics. You just need to remember few formulas. Okay, so this was product rule of derivatives for us. Okay, so Ujjwal says, I have a question in chat. He says, I haven't studied calculus in class 12. No problem. We are starting from the basics. Okay, Ujjwal? There's no need to worry. We are starting from the basics. There is nothing, there is no background needed in this class. I will teach you from scratch. Okay? Can I proceed? There's no need to worry. You just focus on these notes. You just focus on what I'm saying and you will succeed. Okay? All right. Fine. So This was sum rule. This is constant multiplied with a function. This is product rule. Please take care of these warnings. They are very tempting. Okay. Similarly, the last question which we did by quotient rule of derivative. Now this can happen in exams. They will give you something like this, x square upon sine x, and one of the options will be 2x upon cos x. Okay, what they will do? They will differentiate x square, 2x. They will differentiate sine x, cos x. Okay, so you will get 2x upon cos x. So that will not be the answer. You will have to apply quotient rule of derivative. Okay. Okay, Shivani has told me to stop for some time. Okay, I'll pause. Anyone wants to ask something? I will unmute that person. You can either type it in chat or you can raise your hand. Shivani has told me to show the formulas. Don't worry, Shivani. I'll give you the formulas. We will revise the formulas while doing the questions. I just wanted to ask, are you following with me? Are you understanding? Because differentiation and integration has been asked a lot of times in past 3 years. Okay. Shivani, you can unmute yourself and you can ask me your doubt.
Ma'am, I have no doubts, but I want to see that formula slide. I have
Okay.
to write it down. That was my concern.
Okay, Shivani. Okay, fine. Okay, then let's continue with the class. Don't worry about the formulas. Okay. Okay, I'll give you all 1 minute to write down these formulas. And I will add one more formula to the list. The derivative of log x is 1 by x. You can take a minute. This is the formula list. Then next I will show you the quotient rule and product rule of derivatives. Okay, I'll go to, you can write down this quotient rule. I'll wait. Okay, I'll show you the product rule. Just wait. Yeah, you can write down the product rule. This is the product rule. Okay, I'll proceed now. I'll continue with the class. All right. So how we attempt differentiation? First of all, we should know formulae. Okay. Second, we should know basic formulae. Then we should know rules. And third is chain rule of derivatives. Chain rule of derivative is the heart of differentiation. If you know chain rule of derivatives, you know derivatives. Okay. So I will try to explain you the chain rule of derivatives using examples. Okay. How do we follow chain rule of derivatives? What does it mean? It means following a chain to perform differentiation. Okay. So what is the rule? First, we go to the power, then we go to the function, and then we go to the argument of the function. I will explain it through an example. There's no need to panic. Okay. Now, suppose somebody asks you, what is d by dx of sine 7 log 8x? Okay. Now, this will not fit in any of the standard formulas. This will not fit in any of the basic formulas. This will not fit in product rule, chain rule, sum rule, difference rule, quotient rule. What is happening? There is a function log which is sitting inside sine, and there is a function 8x which is sitting inside log. So, what is chain rule? Function inside function. Okay, what we do? Function inside function. Now, just see how am I going to attempt this. Power. Let us look at the power first. So, we will attempt power rule of derivative. Power or rule of derivative says xn goes to n x n minus 1. So, what we are going to do? 7 sine 6. Everything will remain same. Only this 7 will follow power rule. N and n minus 1. And this x is actually this sine. 7 sine 6 and everything remains same. Now, the power is done with. किसकी power थी 7? Sine की. So now we will differentiate everything except this power. Sine log 8x. Okay. So this will be like this. 7 sine 6 log 8x. Now, there is no power, but we have a function. Function. So what is the differentiation of sine? Sine x goes to cos x. So differentiation of sine is cos and whatever was inside sine. Okay. Now, what remains inside sine? Log 8x. Now, I am going to differentiate log. Now, what is the differentiation of log? Log x goes to 1 upon x. So, this log 8x is differentiated to 1 upon 8x. But still, I have 8x inside log. Okay, I have doubts. Okay. Can I know which people have doubts? Which students have doubts? Okay. Shamoita. Yes.
Ma'am, can you show your slide once?
Slide for what?
Ma'am, just like what you were showing now. I have had a doubt there.
Okay, the chain rule?
Yes, ma'am.
Okay, so you stay unmute. I'll show you my slide. Okay. Yes. Now please ask.
Ma'am, here it will be cos log 8x, right?
Yes, yes. That is a typing mistake. I'm sorry.
Yes.
Okay, that's a writing mistake. Okay. Anything else? Anyone else having a doubt? Okay. Can I proceed? Okay. So basically now we will have d by dx of 8x. So now my differentiation will be completed and this is going to be 8. So finally I'll write 8 here and whatever was here. This is my chain rule. Okay. We do not stop differentiating until we go to the function which is sitting inside. Okay. We continue. All right. Okay, I'll explain this through one more example. Okay. What is d by dx of, let me do it like this, log 7 5x. Okay. We will go to the power first. 7 log 6 5x. Then we will go to log of 5x. It will be differentiated as 1 upon 5x. And then we will differentiate 5x. It will be 5. Now, if you want to write it down step by step, it should be like this. 7 log 6 5x into d by dx of log 5x. Okay. Next step, 7 log 6 5x d by dx of log 5x 1 upon 5x d by dx of 5x. Then again you write this thing as it is and you write 5. So is there anyone who is having a doubt with chain rule? Okay, why I taught chain rule? Because we have a question. CUET 2018, question number 47. You have to differentiate y equals to root x square plus 1. That is why I discussed chain rule. Okay, now let us try to do this. Y will be written down as x square plus 1 power half. Root means power half. Okay, now what I do? I will first of all use power rule. So dy by dx would be half whatever is inside raised to the power half minus 1. Okay, power is done with. Now I differentiate whatever was inside x square plus 1. Next step, half x square plus 1, half minus 1 is minus half, and this is going to be 2x. Completed. X square plus 1 raised to the power minus half, x upon under root x square plus 1. So this is an application of chain rule. Okay. Chain rule plus normal differentiation rules. All right. We can discuss one more question of CUET. I give you 10-20 seconds to write this down. If you want to write it down at all. You do not need any basics of differentiation. These are the basics of differentiation. Okay. You should know basic formula number 1. You should know the rules of differentiation number 2. And then you should know chain rule of derivative number 3. That's it. If anyone has a doubt, okay. Fine. Then I can do integration. If anybody has any doubts related to differentiation, you can ask. Otherwise, I'll proceed with okay, Shamoyuta has asked me a question where e raised to the power, okay, e raised to the power y is equal to e raised to the power x minus 5. Okay, somebody has asked me this. I was coming to this. Okay, let's discuss this. Now we have logarithmic differentiation. When do we do logarithmic differentiation? When we have powers as variables. Okay. Now, for example, if somebody asks you y is equal to x raised to the power 1 upon x, and if you do this 1 upon x, x raised to the power 1 upon x minus 1, this is wrong, because in power rule of derivatives, where the derivative of xn is nx n minus 1, we should know that n was a constant. Okay. So what happens when we are given powers in terms of x? Okay. So first of all, I'll pick up a easy question that is asked in 2022 CUET, question number 95. Okay. They have asked what is the derivative of y, x raised to the power x, and x into x raised to the power x minus 1 is given as an option. Okay. Because it's very tempting. People will apply power rule of derivatives. Okay. So what is the step? We take log of both sides. When I take log with respect to the base e, which should be understood. Okay. So we will have log y equals to log of x raised to the power x. Okay. Now we have this rule in logarithms. Log a raised to the power m is m log a. So we will have log y is equal to, this power comes out x log x. यहां तक सिर्फ log की knowledge है. यहां तक we just have to take log on both the sides, and then in this step I just use a rule of logarithms. After this we differentiate. Okay, so what we do? We differentiate both sides with respect to x. Please pay attention to this step. When I differentiate log y, I will get 1 upon y. But I will not stop there, because this is y, not x. So I apply chain rule. So 1 upon y dy by dx is equal to d by dx of x log x. Again, d by dx of log y, 1 upon y, chain rule, dy by dx equals to, I will use product rule here, fx into gx. So fx, which is x, differentiation of log x, which is 1 upon x, plus log x into differentiation of x, which is 1. So my dy by dx would be, this is 1 plus log x. So this y will come here, y, 1 plus log x, and it will be x raised to the power x, 1 plus log x. This is going to be my final answer, this one. Okay. So this is known as logarithmic differentiation. I will come to this doubt. This was asked by one of the students. I will do this right now. First of all, you can take your time to understand this solution and ask me if you have any doubt. Okay, so I assume that no one has a doubt right now. So let me attempt this question asked by one of our students. E raised to the power y equals to e raised to the power x minus y. Okay. E raised to the power y equals to e raised to the power x minus y. Let me confirm the question once again. Yes. Okay. We have powers as variables. So we take log of both the sides. Okay. Now, rule of logarithms. Log a raised to the power m is m log a. So we have y log e. The power comes out. And over here we will have x minus y log e. The power comes out. Now, I told you the base is e. So the base is E and the subject is E. So the answer is 1. If you don't remember this, please write down if the base is A and the subject is A, the log is going to be 1. So we have y into 1 equals to x minus y. Okay? Alright. So we have 2y equals to x. So we have y equals to x upon 2. So dy by dx. Now this is 1 upon 2 into x. So 1 upon 2 dy dx of x, which will be 1. So the dy by dx would be half. This question can be attempted using the properties of functions, one functions, but I will come to this when I will discuss functions. Right now we are doing differentiation. Logarithmic differentiation works. Good for us. One more thing, a very small thing, all of you must be knowing it, and if you don't know it, write it down. Dy by dx can also be written down as y dash. Okay? If your function is fx, its derivative can also be written down as f dash x. So sometimes they will ask you fx is this, find out f dash x, and so on. Okay. I wanted to do integration also, but I think we should do more of differentiation for next 10-15 minutes, whatever time is remaining, so that you people are clear about how to attempt questions on differentiation. It is no big deal. Basic formulas, rules of differentiation, chain rule of derivative. That's it. Okay. So let me do few more questions asked in past years. Okay. So this was asked in, see how easy it is. 2021 question number 50. Y is equal to mx plus c, and they are asking you derivative of y with respect to x. First of all, we should not be calculating the derivative. This is a straight line. Okay, a straight line. This is, you can write this down. Okay, this is a straight line. Straight line with slope m. Okay, and y-intercept c. Okay, so what is actually derivative? Derivative is rate of change. Okay, and what is rate of change? Rate of change is actually slope. Okay, so actually the derivative is m. And if you want to apply your skills of differentiation, dy by dx should be equal to dy dx of mx plus c. Then you split them up, and then you take this constant out. And then dy dx of x is 1. D by dx of a constant is 0. Okay? So if you have anything of this sort, 2x plus 1, what is derivative? 2. Y is equal to 7x plus 3. What is derivative? 7. Y is equal to 8x plus 4. What is derivative? 8. It might take time to do these questions right now, but once you're handy with the rules, it is going to happen very fast. The questions are going to come, the answers are going to come very fast. No need to worry. Okay. So I give you some time to analyze this, see this. As per me, this is not even a question of differentiation. This is something about straight lines. And we encounter straight lines in our day-to-day lives. Okay. All right. Okay. So we were asked this question number 66, 2020. And option A, fx is equal to 6x cube minus 3x minus 2 plus 5x plus 7. Okay, and they gave the derivative as f dash x is equal to 18x square plus 6x minus 3. Okay, so now please apply the rules. Right now we've learned the rules. If we differentiate this, f dash x is going to be 6 into 3x square minus 3 into minus 2 x raised to the power minus 3, because minus 2 minus 1 is minus 3, plus 5 into 1 plus 0. So this will be 18x square plus 6x minus 3 plus 5. Wrong. B. Fx equals to 3x raised to the power 2 by 3. The answer was f dash x equals to 6x raised to the power minus 1 by 3. Let's see. Okay. Let's see. We know the rules. So f dash x would be 3 into 2 by 3 x raised to the power 2 by 3 minus 1, which will be 2. Okay, which will be 2 x raised to the power minus 1 by 3, which is wrong. Okay, then C, fx equals to ax cube minus bx plus c, and f dash x is given to be 3ax square minus b plus c. Now, let's calculate. So, f dash x would be 3ax square minus b. Wrong. That's D. Fx equals to 4x plus 3 by x squared. You see how much practice is done in this question. 4 questions. Okay. So, let's see. So, and your f dash x is given to be 4 minus 6 upon x cubed. Let's see. So, I can write it as 4x plus 3x raised to the power minus 2. This goes in the numerator. So, the power becomes negative. So, let us differentiate. 4 into 1 plus 3 into minus 2 x raised to the power minus 2 minus 1, which is 4 minus 6 upon x cubed. True. So, generally, CUET will revolve around power rule. Simple questions. Sum rule, difference rule. They have asked logarithmic differentiation. You should know logarithmic differentiation. When the powers are in x, they are in variables, you have to take logs on both the sides. Okay. That's it. You should know what is slope. Okay. Because they can even ask you. I'll wait like on this page for 30 more seconds. If you want to copy this down, understand this, then I'll discuss one last thing. Okay. Which can be asked. Okay. Last thing that can be asked is, and this is very important, they will give you some y is equal to something x7 plus 3x6 plus sine x, something. And they ask you, what is the slope of the curve y at x equals to pi by 2. Suppose they ask you this, okay? What is slope of the curve? Rate of change, okay? You have to remember this. That's it. Rate of change means calculate dy by dx. 7 plus 18x5 plus cos x. And finally, input x equals to pi by 2. So that will be 7 pi by 2 raised to the power 6 plus 18 pi by 2 raised to the power 5 plus cos pi by 2. Okay. 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 So this was the last thing that I wanted to tell you. And if they ask you slope of, basically slope of the curve is slope of tangent to the curve. Okay. And if they ask you slope of normal, that would be minus 1 upon dy by dx. Okay. So what is the crux of the differentiation? Basic formulae, rules, chain rule, logarithmic differentiation, basic terminology, that is rate of change, slope, etc. Please focus on concepts and definition because CUET focuses on basics. It should not happen that you are able to calculate derivative of a very high-fi function, which is very complicated, but you do not know if somebody asks you to calculate slope of a curve at a point. Okay? Basics are important. CUET focuses on basics. So that's all from my side today. We only covered differentiation today because I thought we should go slow because some students said that they have not done differentiation at all. So anything anybody wants to ask, share, any questions?
All right, thank you so much, Suman ma'am, for today's class. And we will have to end the session now because we have our next class coming at 7.
Okay.
So, and if you will be having your class again next Monday. So everyone, if you have, please solve questions and for whatever doubts you have, Suman ma'am will again be there on Monday for your next session. And you'll be doing integration next, right?
Yes, because yes, this class is left.
All right. Thank you so much, ma'am. Thank you everyone for joining in. Bye bye, everyone. Take care. See you.